Okay, today we are going to talk about health informatics, and we will talk about how we can use the power of health informatics for accurate classification of various diseases. And we are going to talk today about diabetes. So the objection of today's lecture is just to show how to work with real data. Then we will study the classification of diabetes using real data. And then we'll discuss a new approach, how to boost the accuracy. This is a critical point in applications of machine learning, artificial intelligence to healthcare informatics and public health too. And we'll start with data exploration. In my previous lectures, I just try to underscore that data exploration is a must, has to be done prior to do anything else. So first of all, you have to explore what the data are. And the thing is data sets are. And what is the objective is to predict whether a patient has diabetes based on diagnostic measurements or it doesn't have diabetes. And we take the data from India. This is population data from female patients of Pima Indian heritage, age 21 years or older. And we have number of samples, 760 observations. So for us, it is not a problem because in my previous lectures, we had data with tens of thousands and so forth. It is not a big problem. And so I just urge not to be afraid of if you have a large size of data sets, because with current power of computer, it's not a big problem. The most important is how to process and pre-process data to get reliable and accurate results. So we have a number of features is 8. We'll talk about it. And the target, we call it, is also output, is 1 or 0. It's binary classification. So it is a person has diabetes is, let's say, 1, and doesn't have diabetes, it is 0. All right. So then what we talk about is we need, this is first step, what we do. We see what the data are, what the data sets are, and what the number of observations, number of features. This is, we started the data exploration with these elements. Now, the second step is to talk about features. So features we have in this data set, pregnancies, the number of times pregnant woman was pregnant, a glucose level, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, and age. That's what we have these parameters from the data, Indian data set on diabetes. All right, so we have these features, and now we would like, and if you look at my previous lectures, to plot the data. Not all, because sometimes the data are millions, but just a few just rows you have to see what the data are. Why it is important, and I'll tell you why. Because, for example, we take pregnancies here. Here is 6, 1, 8, glucose 148, 85, 180. So we have quite different range. We have different orders of magnitude of this data. And this is dangerous because when we talk about applying machine learning, many machine learning techniques require that we have features, the data elements of the same order. So looking at this kind of data, we see right away that we need to do standardization of data or normalization of data. Normalization, standardization, that you will have the same order. Why it's important? Because we have, let's say, when we use deep learning, we have weights. We have 2 previous lectures, we discuss it in all detail, so you know how to run, how to build neural networks, and you remember that we have weights. So when we have, for instance, data, the higher magnitude here is thousands, for example, and here is just units. So 6, 1, and so forth. So this column will be neglected. Yeah. So we have to be sure that we do a standardization, and this is part of pre-processing. So just to look at the data of these features. Second, what I always recommend is to plot, to do some visualization. And first, we start with target, with output. So we have the one, it is the diabetes. So we have this orange color shows demonstrates women with diabetes, and blue without diabetes. All right. So then what we also recommend to do to look at outliers. And outliers, it's a very serious thing because outliers can damage the whole procedure because creates confusion, creates outliers, create wrong information that you input in the data. And so even, for instance, your algorithm is quite sensitive, then you will get bad results. So outliers should be removed, okay? And box plot is one of the possibilities to visualize them. And we have powerful methods to remove outliers. I will just talk about it, and already expressed this in my previous lecture. So in this, for example, we see outliers that are glucose 0, for example. So this is outlier because this patient with no 0 is just a simple error in the data set. Same thing is here. We have in BMI over 60 and whatever it is. This is quite high numbers, and this is probably outliers. So you ask questions why we have outliers. And there is many reasons for having outliers. And when we look at the raw data, so we have lots of things, for example, inconsistencies, we have errors in input, there is some human errors when you input data, and so forth. So we have outliers all the time. Now, what we do next, we do histograms. Histograms is two things why it's important. The first thing, we can identify these outliers here that we see in these plots beyond whiskers, and let's say 0 here and 0 here. And also, we have a very important thing. When we do the histogram, we can see if your data shows some similarity with normal distribution, because when you have even skewed normal distribution, we can apply powerful methods. But if you do not have normal distribution, that you have to use some other technique. So in this case, we see that we have some normal distribution curve. And for this, we can use, let's say, Z transform to eliminate distribution. We also discussed in my previous lectures. It is one just sentence in Python code, and we don't have these outliers. So it is very, very simple thing. And then, of course, we have to know to see visualization, how features they correspond to each other. For example, and this is very easy to plot. This is also part of visualization that I always highly recommend to do. For example, we take, let's say, BMI, and let's say this one we plot red, it is when the person has diabetes, and green, you don't have diabetes. So we can see this, for example, that BMI plays quite important role. Already something around 28, like we have quite high risk, quite prevalence of patients with diabetes, so they play quite a high role. Same thing when we can identify glucose, the critical value, when you have a large number of patients with diabetes, when you go, let's say, to this red zone. And same thing, we have age, and that is quite, we do visualization. Another thing is important to build this heat map. in data science, it's very important that heat map shows correlation between different features, for example, outcome, age with pregnancies, BMI, how it corresponds to, how it correlates with blood pressure, and so forth. And from here, you can see that, for example, glucose, it is almost 50, 0.4950, so it is the highest value here. And this is also a major element in feature engineering to see which elements, which features play the most important role in outcome, whether a person has diabetes or doesn't have. So heat map is a good idea. And then you can plot it in this case. For example, you can see that as you saw from the heat map, you can see that glucose plays important role, that BMI, age, pregnancies, diabetes, insulin, and this one, skin thickness, and let's say blood pressure, they don't play much role. And it is up to us to, let's say, eliminate, let's say, these features that is, let's say, less 0.2, and you can have only a few features. But in this case, I do not recommend to eliminate these features. Why? Because when we have features, let's say many features, let's say 50, 100, and so forth, and in my work, I had many features, examples with many features. Then it is very reasonable to eliminate some, because otherwise you'll be confused. You can eliminate some, you will just leave major. But when you have, let's say, only 8 features, I don't think you need to bother with elimination of these things. Already they don't play much role like blood pressure. Okay, so that is when we eliminate features, let's say, less than 0.2, that it is cross-correlation coefficient, then you have only 4 features that play a major role. But as I said, that when we have 8 features, I do not recommend you to do anything. So now a thing is that we will use deep learning algorithm. And you know that in data science, some industries, some people are a little bit skeptical to use deep learning because they always complain that deep learning doesn't give accurate results. So sometimes it's 0.6, sometimes it's 0.7. And so it's not up to snuff, let's say. So it's not something what we desire. Okay, plus there is some computational difficulty sometimes where you have to go, we call it forward feed, to remember, feed forward, and you can have backward propagation when you adjust the weights and so forth, and you have to choose epochs, you can choose batches, and to tune this. And I already, in my previous lectures, I explained how to do it. It's not a problem, a big problem, and you can have just experience, you can build experience to do that. And the one thing is, it is also it's quite good in classification. We have to minimize this norm, and this norm gives you always one result, not like this when we use regression. Then we can have different solutions. Here we have only one unique. So in classification, this is a very good, and we can feel comfortable. The only stumbling block is accuracy. So if we solve this, then the number of industries, the number of, let's say, professionals will be happy to use it if they're sure that accuracy is okay, is good enough. So today we will talk about the accuracy. So when you run different algorithms to the same data set, then we have logistic regression. In my lectures on machine learning, I describe you how to run logistic regression, how to build the results, and how to build prediction and so forth. So you can see that this gives you one of the best, but less than 0.8. Then we have decision tree classifier, AdaBoost classifier, SVC and SVM. It is support vector machines, random forest classifier. And you see that it is a little bit more than 0.7, and the accuracy is not good enough. So people say that, oh, I can say that what does mean 70% of accuracy? Means that it's a little bit more than just to do guess. A person has it, or not. So I have more experience. The doctor said that if I use this thing, I can just look at this patient and I can give a rough estimate if person has diabetes or not, to send him for more analysis and so forth. And also we look at the confusion matrix, and confusion matrix in this case, this one. So we, for example, we have the 89 patients we classified correctly that they have diabetes, but 32% we classified as diabetes free, but they have diabetes. So this is not actually a very encouraging thing. And I would like just to show you uh, a newly developed algorithm that really can contribute to the accuracy, how to boost accuracy and so forth. And it can be used in many applications, not only in healthcare. And this one we call PM, principal model, Gen AP, AI, artificial intelligence. And we also, when we do this, let's say, confusion matrix, we can also print classification report. We can see the accuracy, which was in this case was pretty good. So it is 80, 81. It is better than anything else before we did. Then we have recall. Then we have precision. Okay, and there is, remember, I also we discussed this, what has been precision, what has been recall, the sensitivity. And there is some trade-off between precision and recall. We already discussed this in my previous lectures. So what I would like to show you today, so this how we can boost accuracy, and not only by some percent, but significantly we can boost accuracy. Okay, so when we use PM Gen AI, so what does it mean? That we treat our data in terms of probabilistic data sets. So we just introduce some probability. And then we estimate the probability that this data set belongs to first cluster. First cluster is 0, and second cluster is 1. So it comes with probabilities. And if the probability is poor, we reject this prediction, and we substitute this by synthetic data because GenAI generate synthetic data. And we have amazing results here. We have 82%, 82 where correctly they will correctly diagnosed with diabetes, and only 3 patients who had diabetes, we identified them as diabetes free. So that is much better than anything else. And the accuracy is 97%. 97% is accuracy. So we jumped from 0.81 to 97% using this quite, I don't want to say it's too simple, but this algorithm, which is straightforward, I would say like that, and you can significantly boost the accuracy of your work. So that is, I highly recommend to look at this, and you can generate synthetic data in different way using, for example, Gaussian statistics or Gibbs statistics, doesn't matter. But you will have generated data, and you will reject the predictions that come with low probability. So you significantly boost the accuracy of your prediction. Okay, so conclusion. Machine learning appears to be a powerful tool for accurately classifying various diseases. One of the major elements that degrade the accuracy is the data quality, and we already discussed that. Data quality is one of the most important parameters. And there is a theorem in computer science saying that it doesn't matter what algorithm you have. It can be very sophisticated, but if your data quality is not up to required level, you will never get good results. This is one of the major reasons why even sophisticated ML algorithms fail to be applied to real data, and they cause frustration. So people become a little bit skeptical. So a newly developed artificial intelligence algorithm, namely PM Gen AI, generates synthetic data integrated with observations and rejects the outcomes with low probability. It allows to boost the accuracy of significantly classification accuracy and can be an indispensable tool for health providers. So we finish for today, and I thank you for your attention.